Stars light up our night sky with a heartfelt brilliance, yet in a dim turn of events, around 700 trillion of our stars have suddenly disappeared. As you would expect, researchers were horribly confused, but that was just the beginning. New objects are now emerging from deep space, which we must also quickly figure out. Who or what is behind the baffling vanishing of 700 trillion stars in our universe? Is there a connection between the vanishing stars and these unexplored world objects from deep space? Join us in this video as we delve into the mysterious situation unfolding in space. Researchers warn that more than 700 trillion stars have suddenly disappeared, with something emerging from the dark. We will uncover the possible reasons behind the evaporating stars and explore the emergence of this unknown. Imagine seeing something that looks like a star in an old picture, and then you never see it again. It has taken mankind centuries to grasp concepts like science and mathematics, which help us interpret our role in the universe and the fundamental nature of Earth, even though the core remains shrouded in mystery. One of these central principles highlights the idea that matter can't simply disappear, it must change. Consider, for example, an individual disappearing after diving into molten magma. Disappearing is just the final stage of a scientific event. The matter undergoes a significant modification before transitioning into a different form. Likewise, when a star explodes and vanishes, its constituent matter disperses throughout the cosmos, persisting in another form. We bring up this point because a puzzling conundrum has surfaced in the depths of outer space, one that currently lacks a definitive explanation: the vanishing of stars from our night sky. At first, this might not seem particularly remarkable, given the vast scope of the universe, where the sudden vanishing of a star can be attributed to various factors, such as reaching the zenith of its life cycle or succumbing to the gravitational pull of a titanic entity like a black hole. However, what makes this situation confusing is that the disappearing stars are not isolated incidents. They are numerous, numbering in the trillions. Recent estimates show that more than 700 trillion stars have mysteriously disappeared, leaving astronomers baffled as to how they could have suddenly flickered out of existence. While the vanishing of a few stars can be explained in a universe of such scale, the evaporating of hundreds, especially those not nearing the end of their life cycles or threatened by external forces, presents an entirely different problem. Fortunately, some dedicated scientists are tirelessly working to unravel this vast mystery. Beatrice Villarroel of the Nordic Institute for Theoretical Physics in Sweden sheds light on their efforts, saying, "VASCO, or the Vanishing and Appearing Sources During a Century of Observations project, is our undertaking." She further says, "We are intrigued by various vanishing objects, but our ideal interest is to identify a star that has maintained a constant presence in the sky for as long as human memory and available data can recall, only to suddenly disappear. Even the most advanced telescopes fail to reveal any remnants. It is essential to recognize that this is not just a whimsical pursuit. The VASCO project has been active since 2017 and has garnered significant attention." Villarroel explains that the project has attracted interest from astronomers across diverse fields, including experts in active galactic nuclei, stellar physics, and CT researchers, each driven by their unique motivations to participate. The team acknowledges that certain aspects of the universe remain unpredictable, given our limited ability to catalog every celestial object with absolute precision due to vast distances. Nevertheless, they remain confident that discovering a specific kind of star suddenly vanishing from the sky could yield groundbreaking insights. Villarroel emphasizes this potential, stating that while they understand the existence of variable stars, their changes typically occur over a few years at most. The quest is to find a star that changes from unwavering stability to complete vanishing, a phenomenon that has not yet been documented. Such a discovery has the potential to uncover new realms of physics. Perhaps you're wondering, is it really possible for a star to just disappear without warning? The answer is yes. For instance, a star was under astronomers' observation for an extended period, spanning 20 years until 2019. Their fascination with this star was partly due to its stunning crystal blue brilliance. Then, suddenly, it ceased to exist. Andrew Allen, a doctoral student specializing in astronomy at Trinity College Dublin, meticulously examined and reanalyzed the data. The star's vast distance made it impossible for telescopes to directly observe it. Consequently, astronomers searched for the distinct signatures of these luminous blue stars in the light spectrum from their parent galaxy. Incredibly, these obvious traces had vanished during that period. The leading hypothesis suggested that the star had undergone a supernova explosion, leading to its transformation into a black hole. However, there were no specific signs of a supernova event or the expected aftermath, nor was there any visible black hole. Considering the delay between observations, it was highly unlikely that such a dramatic event had escaped notice, as emphasized by Shachar Reva, an astronomer affiliated with Tel Aviv University. If, indeed, the star transformed into a black hole without any supernova activity, it presents a scenario of vanishing without the usual spectacle, a phenomenon astronomers have been seeking answers to for an extended period. With this, Reva suggests that some stars might transition directly from their dying stage into becoming black holes without a. The passage discusses several intriguing astronomical phenomena, centering on the mysterious disappearance of stars and the exploration of vast cosmic voids. It starts with the mention of stars that seem to vanish, referencing an event dating back to 2009, when a star suddenly transformed into a black hole before scientists could fully understand it. Despite the absence of conclusive evidence, this and other similar events have left astronomers perplexed. Scientists have used large catalogs of stars to study these occurrences, leading to discoveries of transient objects that appear and then vanish, challenging traditional classifications of stars like M-dwarf flares or novas. The vanishing of stars could be explained by the immense time it takes for light to travel across the universe. The stars we observe may have already ceased to exist, but their light is only now reaching Earth. This suggests that some of the stars' apparent disappearance could be due to the long time delay in the arrival of their light, though other complex and unverified ideas also persist. One extreme hypothesis involves advanced extraterrestrial civilizations constructing Dyson spheres, massive structures designed to harvest energy from stars. While purely speculative, such concepts resonate with science fiction ideas, though they face significant technological challenges and remain unproven. The passage then shifts focus to vast cosmic voids, regions of space with very few stars or galaxies. One notable example is the Boötes Void, an enormous, nearly empty region in space measuring 330 million light-years across, containing just a handful of galaxies. This void, along with others like it, contrasts with more densely populated areas like the Virgo supercluster, where galaxies are much more tightly packed. These voids represent significant gaps in the universe's structure, posing mysteries about how they formed and why they contain so little matter. In essence, this text presents the enigma of disappearing stars and the exploration of cosmic voids, raising profound questions about the universe's structure and the forces at play. The European Space Office describes the Boötes Void as one of the loneliest regions in the universe. How this cosmic system appeared in such isolation remains a mystery. In this observation, you can recognize 3 foreground stars, all from our Milky Way. All other points of light are distant background galaxies, resembling a multitude of microorganisms in a drop of water. But how do these voids come into existence? Virtual simulations have shown that smaller, more common voids result from the gravitational attraction of galaxies pulling closer together, leading to the depletion of neighboring regions. However, this explanation can't apply to the Boötes Void, as there simply hasn't been enough time since the universe's beginning for gravitational forces alone to clear out a space of such colossal proportions. This brings us to the theory of the Big Bang. When most people imagine the universe's expansion following the Big Bang, they likely picture a uniformly distributed scattering of galaxies retreating from one another. However, a more complex structure emerges when we examine the universe on the grandest scales. For example, squeezing billions of light-years into a computer screen-sized cube, we must rewind the universe's clock to its earliest moments. Soon after the Big Bang, the universe was a dense region of intensely hot plasma. At that time, despite its predominantly uniform density, there were minute variations or quantum fluctuations in spacetime. As the universe expanded, these minor variations in matter density became increasingly pronounced. As a result, regions with higher and lower matter densities emerged on a grand cosmic scale. Fast forward 13.8 billion years from the Big Bang, and we can see how these small deviations at the dawn of time developed into the giant structures we see today. These structures include vast walls, each consisting of millions of galaxies. Rather than individual galaxies, they are interconnected by nodes where filaments of galaxies converge. These are giant structures stretching millions of galaxies wide and many megaparsecs across. The spaces or voids between these galaxy clusters are even more expansive. Specifically, these voids aren't entirely devoid of matter, they are less dense than regions filled with galaxies. Their matter density usually amounts to about 1/10 of the universe's average density. Consequently, these voids still contain dark matter, gas, dust, stars, and galaxies, but in smaller numbers. For instance, there are 17 distinct galaxy clusters within the Boötes void alone. As the universe expands, these voids, like the Boötes void, will continue to grow. The walls and filaments connecting galaxy clusters will stretch and break, leaving only gravitationally bound groups of galaxies in the expanding void. As these voids merge, the sheer size of the observable universe is truly staggering. Meanwhile, our location within this vast universe is part of the local group, a portion of the Virgo supercluster, situated on the edge of a massive cosmic void. Yet, there is still much to discover in this enormous expanse. So far, astronomers have identified the largest known structure in the universe, a vast void known as the supervoid. This supervoid spans an astounding 1.8 billion light-years in diameter and stands out for its remarkable emptiness. The supervoid offers answers to questions that have fascinated scientists for over a decade, while also raising new inquiries that hint at the emergence of alien physics. The amount of cosmic matter, including galaxies and dust, within the supervoid is roughly 20% less than in the universe's general region, or any area with a typical density. While it isn't entirely empty, it certainly feels like a vast and cold wasteland compared to other areas of space. The supervoid's existence connects to the discovery of the cold spot, a region of space noted over a decade ago for its unusual size and lower temperature. This is different from what would have been expected, given the cosmic microwave background, CMB, radiation, the warm radiation left over from the Big Bang. Researchers have been searching for a void within this area because, as photons travel through an expanding universe, they lose energy and cool while passing through a void. The era of accelerated expansion, which seems to have begun roughly 5 billion years ago, remains a mystery for astronomers. Dark energy was a clever term for this massive cosmological puzzle. But what connection does dark energy have with these cosmic voids? One significant reason is that the effects of accelerated expansion are not noticeable within star systems or galaxies, due to the dominant gravitational pull of matter. Dark energy, for instance, hasn't caused the Milky Way or our solar system to expand. However, since cosmic voids are extremely sparse in matter, they are far more susceptible to the effects of dark energy. Therefore, it seems prudent to investigate the nature of this accelerated expansion in the regions where it leaves the most impact. A recent study suggests that dark energy is not only present in voids but may also be a consequence of their existence. This raises the question of how these vast void regions may induce faster universal expansion.